This video is a tutorial on multiple target debugging using ASH WARE's DevTool-based products such as our eTPU Simulator IDE and our MC33816 Simulator IDE. Multiple target debugging refers to when multiple targets are being co-simulated, such as multiple eTPU engines and/or multiple MC33816 cores. Let's open up our eTPU MC33816 System Simulator demo from the Windows Start menu. These three targets can be seen in the project window here, here, and here. Each of the three targets also has its own activation button here, here, and here. Note that only one of the three targets can be the active target at any one time. So which target is the active target? Target is highlighted yellow in the project window. Also, the active target's activation button up here is selected. Let's do an experiment. Let's set two breakpoints, one in the eTPU's CAM initialization code here, and a second breakpoint in the MC33816's injector boost code here. Now let's run the simulation by clicking the Reset and Go Forever button. The simulation stops in the eTPU code at about 20 simulated microseconds when it hits this breakpoint in the CAM code here, as indicated by this line of source code being highlighted yellow. Since a breakpoint in the eTPU causes simulation to halt, the eTPU target is automatically made the active target, as indicated by the eTPU target being highlighted in the project window and by the eTPU's target's activation button being selected. Now let's run the simulation a bit further by pressing Go. The simulation runs until about 2.3 milliseconds, but then hits a breakpoint in the MC33816 code, as seen by its source code line being highlighted yellow. Specifically, the MC33816's Core 1 hit the breakpoint, which I can see because its activation button is now active, and it is now the target highlighted in the project window. Note that the eTPU's activation button is no longer selected because only one target can be active at a time. So one purpose of the active target is to indicate which target caused the simulation to stop. But the active target has another function. It also tells the IDE which target to act on when doing target-specific things like stepping the code. So I'm going to activate the other MC33816 core 0, by pressing its activation button. Then I'll single step it. Core 0 has been idle, so it takes until 3.8 milliseconds before it steps a line of source code. Let's step several more times. Note that on each step the yellow lines change, indicating that Core 0 is stepping down through its source code, one source code line at a time. Some steps take longer than others due to the core waiting idly at a wait instruction. Now let's switch the active target to be the eTPU. Although I could do this by placing another breakpoint in the eTPU's source code, then running it until a breakpoint is hit, it is far easier to simply click the eTPU target's activation button. Notice that as I now single step, it is the eTPU source code's yellow active line that moves as the active target is stepped. That's it for this feature tutorial. Thank you for watching. Note that we have additional tutorials covering other DevTool features on our website at ashware.com/product_videos.htm, all lowercase. There are also videos covering various ASH WARE product demos at the same location. ASH WARE, development tools since 1994.